It is the study of triangles. Okay, it's all about triangles and the relation and the ratio between the sides. Okay, in trigonometry, we only see the triangles and the relation between the sides. Let's say we have a right triangle like this, and here is our angle. Let's say this is alpha, and this is 90 degrees. Okay, if this is alpha, this side will be adjacent to it, right? Adjacent. We call this adjacent. ADG, adjacent. And this side, as you can see, the opposite of this angle. That's why we call this opposite. And this side is hypotenuse. Why this is called hypotenuse? Maybe it comes from the mathematician that was called hypotenuse. I don't know. Okay, so we said that trigonometry is all about the triangles and the ratio between them. So sine alpha means that I am taking the ratio of opposite side of the triangle with adjacent, sorry, with hypotenuse. Cosine alpha is the ratio of adjacent of the angle divided by hypotenuse. Tangent alpha is the ratio of opposite divided by adjacent. And cotangent alpha is adjacent divided by opposite. As you can see, it's all about ratios of one side to other side. How much bigger is opposite according to hypotenuse. Okay, that's it. That's the definition and the introduction with trigonometry. If you understand this very solidly, that means you have understood 99% of trigonometry.
Mr.
Yes.
Sir, is this last part, the last equation, is it extra one? Cotex, cotangent.
Whatever I write in here is not extra. Okay.
Sir, no, because in trigonometry we only covered the Socrato, the sine, cosine, tangent. This one is new, sir. I didn't see it before.
It's not new.
I don't know, sir. Maybe it's that.
We covered that, yes. We don't cover cosecant and secant. Okay, we have secant x alpha, let's say, and cosecant alpha, but we don't cover it here in SAT, okay? Because in SAT, I don't think that the examination is all about mathematics. It's not about mathematics. It's about problems that you will face in your daily life and turn them into mathematical form and solve it. That is the questions in SAT, not mathematics. Mathematics, they just, the questions, for example, let's say sine alpha divided by cosine alpha is equal to what? This is mathematics, but you will not see any question like this in SAT. You will have a problem and you will convert this into mathematics and solve it. So SAT is not about mathematics only.
Okay.
Okay. And we have some formula. You need to memorize them. Sine squared of anything, of any angle, doesn't matter. Any angle plus cosine squared of any angle is always equals to 1. is always equals to 1. Okay, this you should
Teacher.
memorize. Yes.
Teacher Mub,
Yes. Yes.
I cannot see your screen.
Do you have this problem for like 1 hour?
No, teacher. Like before maybe 10 minutes, I have this problem. For 10 minutes, maybe.
What about the others? Do you have any problem with your screen?
No, no.
No, sir.
No, sir.
No, sir.
Mohammed, maybe you should turn off your device restart it again. It might help. Okay. Which cos 89. Cosine 1 is bigger than. It's really important, by the way. If you're going to study engineering, it will be really important for you to know, I mean, to understand, to feel. I mean, when you see something cosine an angle, you have to imagine, you have to project that scenario. For example, what is that angle? What does it mean? What's that value? You should be able to maybe say the approximate value of these terms, cosine 1. You will see it in engineering. But if you're going to study medical, of course, you will not see anything else. Okay. So, if we have a triangle like this, and this is my angle, alpha, let's say. This is, let's say, x, this is x, y, and z. Okay. And we have another triangle like this. Let's say this is M, N, and let's say this is B. Okay. So sine, let's say this is beta, and this is alpha. Which one is bigger, sine alpha or sine beta? First of all, I mean, if you look at the graph, you can say directly which one is bigger. As the angle increase, as you can see, this is much bigger than this one, right? This one is a bit smaller, maybe, but this one is a bit bigger. As the angle increase, this side also increases, right? When you make the angle bigger, let's make it like this. Sorry. Let's make it like this. This is bigger angle, right? As the angle increases, this side also increases. When that side increases, what was sine alpha? It was opposite, which is x, divided by z. When x increases, that means sine, the value of sine also increases. So sine, let's say 89, is bigger than sine 1. Why? We prove that as the angle increases, the sine value increases. Why? Because this value increases. That is why my value also increases. What about cosine? Let's play this. Cosine alpha and cosine beta. In here, we have bigger angle in here. Bigger angle, but in here we have smaller angle, right? As you can see, cosine alpha, as you know, cosine alpha is equal to y over z. So z remains constant if we change the angle, the hypotenuse. But what about y? In here, the angle is bigger, but this side is smaller. But in here, angle is smaller, but this side is bigger. That means as we decrease the angle, the value of cosine increases. So I can surely say that cosine 89 is smaller than cosine 1. Okay. Let's clean this. Okay. Until now, do you have any question? And by the way, yes, do you have any question?
Sir, later, can you explain the sign again, sir?
Sure, later. And after this, after the session, I will be giving you information about the universities, and we will check together some universities, what type of examination they will accept while applying, and how to apply to those universities, and also maybe a bit of update on how the SAT and when the SAT will happen. Okay.
Sir,
Yes.
sir, why is not SAT test done online?
They are working on it.
Are they?
This is not relevant question for now.
Mr. It is because most of the students in our class, they asked this question, but you did not reply.
Okay, you can ask it in guidance and I don't know, that hour, that session.
Okay, I'll repeat it again.
Guidance and consulting. Is that true for a class like that?
Yeah.
The name of it, Okay.
They're like rehberlik in Turkish.
What else do we have? Okay. And now we will be talking about trigonometry in XY plane. The angles and there, and how to change them. Let's say that this is 0 degree, okay? When I go from here to here, the angle will be 90 degree. So this will be 90 degree. Or in terms of radians, this is 0 as well. And this is pi over 2 in terms of radian, okay? This is in terms of degree. This is in terms of radian. You know how to convert degrees into radians? The formula is r over pi is equals to degree over 180. And in here, in terms of degree, we have 180 degree. If I start from here to here, it will be 180 degree. And in terms of radian, it will be pi. And here, in terms of radian, it will be 3 pi over 2. And in terms of degrees, it will be 270 degree. And again, if I come from here to here, it will be 2 pi or 360 degree. Okay. Let's name the sections. This is from here to here. This is section number 1. Number 1. This is section number 2. From 90, this is 90 degree, until 180 degree, we call this section number 2. And here, this is section number 3. Section number 4. I will take in this line. Why? Because this is really important line. It changes the sign. Okay, it changes the sign. Okay. Let's say if we have sine 150. Okay, 150. How can I convert this angle 150? Because in a triangle, we don't have an angle something like this, 190. Because in a triangle, the summation of all angles is 180 degrees. So there can't be any angle with 190 degrees. So that's why I will convert this into degrees between 0 and 90, because I have to find a relation in a triangle, because this is trigonometry. That's why I need to convert this into 0 and 90 degrees. How can I convert this? We'll cover this. Okay. Let's say if we have sine 150, I need to convert this into 150 into between 0 and 90. So that's why 150 degrees here, somewhere here, right? If I start from here to here, to be 150 degrees. So I know where 150 is, which is in second section. Before that, let me write it here. In first section, all of the signs are positive. Okay, all the signs are positive. A, all of them. Sine is positive. Cosine is positive. Tangent is positive, and cotangent is also positive. And in second section, we use this formula, this maybe way of memorizing this. Stack A, all of them. In second, this is first section, this is second section. And second section, only sine is positive, the others are negative. Sine is positive, and the others are negative. Cosine is negative, tangent is negative, cotangent is negative. And in third section, and in third character here is t. So t stands for tangent. Only tangent and cotangent is positive. Why? Because tangent is reverse of cotangent. 1 over tangent is equal to cotangent. Why? Because tangent is sine over cosine, but cotangent is cosine over sine. So if tangent is positive, that means cotangent is also positive. Let me clear this.
Mister, can you repeat the last part, please?
Yeah, sure. Tangent is equals to, let's say not tangent alpha, an angle, is equals to sine of that angle divided by cosine of that angle. As we have here. Here we wrote in terms of sides, adjacent over opposite, or opposite over adjacent, right? We don't have sine cosine. Let me write it here. Tangent was what? Tangent alpha was sine of alpha divided by cosine of alpha. What is sine of alpha? Opposite over hypotenuse, right? opposite over hypotenuse. And what is cosine of alpha? Adjacent over hypotenuse. Adjacent over hypotenuse. And when I multiply it, when I take this here, it will be reversed. I will flip it over. It will be opposite divided by hypotenuse multiplied with hypotenuse divided by adjacent. Am I right? So this will cancel out. So the outcome will be opposite over adjacent, as we wrote here. So basically, cotangent is also equals to cosine of that angle divided by sine of that angle. Okay, and tangent is sine over cosine, and cotangent is cosine over sine. That means tangent alpha is equals to 1 over cotangent of that angle. Reverse of it, okay? Let's say Ali is equals to reverse of my, okay? Anything that Ali does, I don't do it.
Okay.
So here, yeah, signs of these terms. So in here, all of them were positive, and only sign was positive according to this hashtag. And in third section, only tangent and the reverse of it, which is cotangent, is positive. The others are negative. Sine is negative. Tangent is positive. And reverse of it, which is cotangent alpha or cotangent theta, is positive as well. Why? Because basically tangent is equal to sine over cosine. If both of them are negative, if this is negative and the cosine is negative, 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 positive. That's why this is positive. And in fourth section, if we come here, it says C. C stands for cosine. Only cosine is positive. The other terms are negative. Sine is negative. Cosine is positive according to this aspect. Tangent is negative. Cotangent. Okay, just out here, and the only way to memorize this is work on it. If you work enough on the question and also in this, you'll something like your name. You know your name really good. I mean, you cannot forget that when anything happens. And it will be the same from as well. Understanding, you have to. I look at the angle. The angle is located at second section. In second section, cosine was aspect. S was positive in second section. The others were this, right? Oh, let me convert this. So it will be cosine. You can either write the boundaries. This is boundary number 1, 90. Boundary number 2, 1, which is 90. And 90 degree is in this line. This line is really dangerous. Okay? It changes the sign. If anything passes through this boundary, 90 or 3 pi over 2 or 270 degrees, it changes the sign. As you can see, here my cosine is passing from 90 That's why it will change the sign. Cosine will be converted to sine, and if it was sine, it will be converted to cosine. And tangent to cotangent, cotangent to tangent. So 90 changes the sign. Cosine will be sine. I will get rid of this, and I will write this one here. 60. About the sine, I look at the first form of this term. It is cosine 150. Cosine 150 is in second section, which is, and there cosine was negative as stack. AS was in second section, only sine was positive, cosine was negative. That means it will be negative. That easy. Let's solve some more example of this. Sine, let's say 210, cosine 300, tangent minus 10, tangent 400, let's say, cotangent 170, and that will be enough. Okay, so 210. Let me write this in this row with boundaries. 210 is close to 180. Okay, we can write this as this one, sine 180 plus 30. Am I right? With this boundary, or I can write this with other boundary. As you know, 210 is somewhere here, right? If I start from here to here, it will be 270 degrees. Sorry, 210 degrees. So I can write this with this boundary or with this. Doesn't matter. It will give the same answer. Let me write it with other boundary, which is, I can write sine 210 as 270 minus what? Minus 60. Am I right? I can write it with this boundary because 210 is here. I can write it with this boundary or with this boundary. Doesn't matter. It will give you the same answer. But there are some differences between boundaries. Some boundaries will change its sign, and some doesn't. As you know, 270 is dangerous. It changes the sign. Okay. So if it was sine, then it will be cosine. Cosine what? Just cancel 60. And about the sign, if it's positive or negative, I look at the first one. It is 210. 210 is in third section, and sine 200. I mean, sine in this was it only tangent and cotangent was positive, sine was negative, so it will be negative. So I get this with this boundary. What about this one? Using this boundary, as you know, 180 is in this line, so this line is safe. It's not dangerous. It will not change the sign. So it will be sine 30. I get rid of this. About the negative or positivity, I look at the angle and also the sign. Sine is 210. The angle is 200, and it is sine. Sine was negative in there, so it will be negative. So I got minus sine 30 here using this boundary, and I got minus cosine 60 using the other boundary, using this one. Or did the same. It should be the same. Why? Because when I use this boundary, it gave me this one. When I use the other boundary, this one, it gave me this one. So these should be equal. Or they equal minus sine 30 equals to minus cosine 60. When you use calculator, you will find the same answer. Sine 30 is equals to cosine 60. Okay. And let me solve these terms, but I will solve this in with using one boundary. Okay, I will not use solve like this using two boundaries. One boundary is enough. Okay, cosine 300. I can write cosine 270 plus 30. 270 is dangerous. It changes the sign to be sine 30. Is it positive or negative? It is 300 degree. 300 degree is somewhere here because it passes 270. So cosine in this section was positive, right? As stack. So it will be positive. That's easy. So it will be positive sine 30. And in here we have negative angle. But there wasn't any negative angle. What I do is I put 360 in it until it's positive. Let's say this is sine minus 1000. I put 360 until it is positive. I can put as much as I want into the angle. Doesn't matter. I put 1, 2, 3, 4 until the angle is positive. So this is minus 10. I put 360 in order to make it positive angle. So it will be tangent what? 350. Now I can write this using the boundaries. Tangent 360 minus 10. 360 was not that dangerous. So it will be tangent 10. The sign will not change. But what about the positivity and negativity?
Sir,
350 is here, right? So tangent was negative here, so negative. So this is my answer. And for the others, yes.
sir, continue.
And here, my angle is not between 0 and 360. So when it was negative, I put 360. But in here, my angle is not between 0 and 360. That is why I subtract 360 from it. So it will be what? Tangent 40, right? If I change the angles, if I put 360 or subtract 360, it will not change anything. Okay? It is 140, that's it. I can subtract or add 360 triangles as much as I want. It won't make any difference. Yes?
Why 360?
Because it is a complete circle. Okay? How can I give you an example about this? Yeah, sure. Let me give you an example. Why 360? Why 300? Why not 100? Why not 90? Let's say we have an angle here. This angle, okay? This is 60 degree. Okay? If I add 360, it will come here, back again. So it is the same thing. I rotate as much as I want. It will come the same place. It is always 60 degree. Rotate like this, like this, like this, like this, like this, or backward, like this. Backward means subtracting 360. Backward, it will come the same place. So it doesn't make any difference. It is always 60 degree. Okay, did you understand?
Yes.
So we are done with that. And I want to solve one question, then we will be done with trigonometry for now. If sine, let's say beta, is equals to x, what is cosine beta. What is cosine beta? When you have these types of questions, you draw triangle. Okay, you draw triangle. This is my triangle. Let's say this is beta angle. Okay, beta angle. Sine beta is x. That means opposite this side over this side is x. I can write it like this: sine beta is equals to x over 1. Am I right? Does it make any difference? No. This is x and this is 1. That means this is x, this is 1. Because sine was opposite over hypotenuse. I need to find cosine beta, right? Cosine beta was this side divided by hypotenuse. But I don't have this side. I use Pythagoras formula. Let's say this is m, okay? This squared plus this squared is equal to this squared. X squared plus m squared is equals to 1 squared. Am I right? According to Pythagoras. I need to find this angle. So I put it here. M squared will be 1 minus x squared, right? I need to find m. M is what? M is equals to root of 1 minus x squared. When I take the square of both sides. So I found this angle, sorry, this side, which is 1 minus x squared inside second root. So what is cosine? Cosine beta. This side, which is 1 minus x squared inside second root, divided by hypotenuse, which is 1. So this is equals to cosine beta. Similarly, you can find tangent and cotangent for this question. So the session is over, and I will give, wait, I will give a 15-minute break. Then we'll be discussing about the universities and the examination.
Sir,
Yes.
Okay,
this,
sir.
do we need all of the information about the sine and cosine, the